Okay, so if I have two numbers, A and B, that are real numbers, we want to define, so we're going to let A and B be real numbers, and we're going to define A star B as 5 times AB. So I want to prove or disprove that A star B is associative, is commutative, and has an inverse, and has an identity. So the first thing we're going to do is we need to prove associative. So what does associative mean? Associative means A star B star C with grouping symbols is equal to A star B star C. So let's start this proof. So I'm going to let three numbers, X, Y, and Z, be real numbers. And I want to see if X star Y star Z equals, X star Y star Z. So now I want to do, I'm going to erase all these little dots that I seem to be making with my fingers. So I want to do one side and then see if it works. So let's start at the parentheses. So X star Y translates into 5AB. So 5XY, parentheses, star Z. This becomes the entire A quantity. So this becomes 5 times 5XY times Z. So 25XYZ. Let's see if that ends up equaling the right-hand side of our equation. So X star 5YZ, because this is the A quantity, this is the B quantity, so remember it translates to that. This becomes 5X times 5YZ, which equals 25XYZ. Now this is terrestrial multiplication, so we know it's commutative, so I can rearrange things like that. But let's see if this operation is now commutative, because it's definitely associative. So the associative property holds. Let's see if it's commutative. So commutative, remember that's A star B equaling B star A. Will that happen? So we still have our numbers X, Y, and Z. So X, let's see if X star Y is equal to Y star X. So that's 5XY. Does that equal 5YX? Well, since these are real numbers, and real numbers are commutative under multiplication, and that's what we're actually doing, this is indeed equal. 5XY equals 5XY. So that one's good. Oopsie. Get smaller. This tool is not working as I would have liked it to work. I want to, no, I don't want to add anything. I want to, no. Okay. Alright, well, we're gonna roll with these punches here. Does it have an inverse? Does it have an identity? So let's first do the identity. So identity. So if I have some number and I'm starring it with something else, will I just get that number? So is there any way that I can put in a number here and just get A? So let's try it. So let's put in an unknown value here. So a star x is equal to 5ax. And I want to know if there's a quantity that makes that equal to a. So I'm going to divide both sides by 5a because this is just terrestrial multiplication, so I can do that. So that x would have to equal 1/5. So if I have anything, star 1/5, it should just be that anything. So let's try it. So I have a star 1/5, and that's 5 times a times the 1/5, and that equals a. And of course it would work backwards as 1/5 star a equals 5 1/5 a. That also just equals a. So we do indeed have an identity. So now the question is there anything that I can put in there to always get the identity? So for the inverse. So I'm going to make this, this is not supposed to be doing it this way, but whatever. So now let's look at the inverse. So a star something, does that exist to give me 1/5? Let's try it. A star something equals 1/5. This is 5ax equals 1/5. I want to solve for x, so x equals 1/25 a. So let's try an example. Will I get 1/5 when I put something in here? So let's a star 1/25 a. What does that equal? Well, that translates into 5a times 1/25 a. The a's cancel, the 5 cancels, this becomes 5, so this is 1/5. So we do indeed have an inverse. So I'm going to still let a and b be real numbers. And a star b will be defined as 3a minus b. So again, I want to prove or disprove associative, commutative, identity, and inverse. So we know the associative is a star b star c equals a star b star c. Does this equal this? This is the property. Let's find out. Let x, y, and z be real numbers. So let's see, does x star y star c equal x star y star z? That should be a z, not a c. Okay, so x star y is 3x minus y star z. So this is now my a quantity, so this is 3 times 3x minus y minus z. So that is 9x minus 3y minus z. Does this right-hand side line up? So let's do the parentheses first. So x star y star z is 3y minus z. X star 3y minus z is 3x minus 3y minus z. So, oops, I forgot to, in the example, in the PDF example, I did not carry over the sign. So this should be 3x minus 3y plus z. The PDF has an error. PDF has an error. Okay, so does 9x minus 3y minus z equal 3x minus 3y plus z? Nope. No, it doesn't. So not associative. Okay, now let's check commutative. So does A star B equal B star A? So we still have our x, y, and z. So does x star y equal x or y star x? So let's check. This becomes 3x minus y. And this becomes 3y minus x. Are those the same? No, they're not. So not associative. Put that up there. I'm learning things. Okay, so let's see if there is an identity. So an identity would mean if I have A star something, will I always get that the A back? There is nothing that I can put in there to only get an A when I try. Okay, so if I had A star B, that would always be 3A minus B. So there's nothing that I can put in there to give me just an A. Okay, every single time. So now let's look and see if there's an inverse. If there's no identity, there's probably not an inverse. And there is not in this case, because if... So there's no... Sorry guys, I'm fried. It is 5:15 on a Tuesday, and I can never get my stuff together on a Tuesday. So... No identity, no inverse. There are other examples on Play-Doh that'll help. Hopefully that will be enough to get you through this problem.